this problem, I need to find the equations for the lines that are tangent and normal to the graph of y equals secant x at the point x equals pi over 4. So let's remember something here. The derivative is the same thing as the slope of the tangent, which is the same thing as the rate of change, the instantaneous rate of change. So if I want to find the equation for the tangent of the secant x, what I need to do is I need to find the derivative of secant x. And just looking at my calculus formula sheet, I know that the y prime is equal to secant x tan x. So the slope of the line that I'm looking for is, so y prime is equal to secant pi over 4 times tangent pi over 4. Well, let's kind of work this out step by step. That's the same thing. Secant is 1 over cosine, so it's 1 over cosine pi over 4 times, well, tangent pi over 4, since sine pi over 4 is radical 2 over 2, and cosine pi over 4 is radical 2 over 2. This is going to be times 1, because tangent pi over 4 is going to be 1. So secant, so this is going to be equal to 1 over radical 2 over 2. That I want the reciprocal of that. So the reciprocal is equal to 2 over radical 2, and I'm going to rationalize it. And I get 2 radical 2 over 2, and it's radical 2. So my y prime, or my y prime at pi over 4 is equal to radical 2. That is the slope of the tangent line. The slope of the tangent line for the function secant x. So the point that I'm going to be dealing with is the point, my x value is pi over 4. See, right there, pi over 4. And my y value is radical 2. So if I want to find my tangent line, I'm going to use the point slope form. Y minus y1 is equal to m times x minus x1. So I have y minus radical 2 is equal to radical 2 times x minus pi over 4. So in order to put this into my calculator so I can check my answer, this is a fine answer. This is in point slope form. Nothing wrong with that. I'm sorry, this is not point slope form. This is in, yes, point slope form, right? 1 point, 1 slope. If I want to put it in the slope intercept form, I'm going to have y minus radical 2 is equal to radical 2x minus radical 2 pi over 4. I'm going to put that in parentheses. So I have y is equal to radical 2x minus radical 2 pi over 4 plus radical 2, moving this radical 2 to the end of that expression. Or if I wanted to make it just a tiny bit simpler, y is, if I could pull out the radical 2 here, radical 2 x minus pi over 4. In other words, leave it the way that I had it right here, and just add the radical 2 to the end. So this is the slope of my tangent line. This is the equation of my tangent line, right here. Now, before I go on, I think I should stop and kind of go back and clarify something. So we were calculating the slope. We were calculating the equation of the tangent at pi over 4, and we came out that the slope was equal to radical 2. And then I kind of jumped to this, that this is the point that I was looking for. And the thing that I want to make sure is that I'm not confusing you on is, this is the slope right here. We calculated the slope. But I'm also needed to find out what was the y value of the point when x is equal to pi over 4. Well, and it's somewhat coincidental that it's the same, because this is our function, secant x. So if our function y is equal to secant x, and I want to find y at the x value pi over 4, then I'm looking for secant pi over 4. And that's the same thing as 1 over cosine pi over 4. And I would follow the same procedure as I did right here. It's just coincidental that they're both equal to radical 2. They won't always be, the slope won't always be equal to the same as the y value of the point. But I wanted to make sure that was clear. So now I have the equation of the tangent line, and I need to find the equation of the normal line. So the normal line means that the slope is the negative reciprocal. So if our tangent line slope is radical 2, our normal line slope is going to be equal to 1 over radical 2, negative, the negative reciprocal. And let's rationalize this. So it's going to be equal to negative radical 2 over 2. Well, I have the same point I'm working with. This is the point that I'm working with right here. Pi over 4 radical 2. So I'll write it here. Point pi over 4 radical 2. And I'll put it in point slope form. So I'm going to go y minus y1 is equal to m times x minus x1. And in this case here, I have y minus radical 2 is equal to negative radical 2 over 2 times x minus pi over 4. And I think I'll just add the radical 2 to both sides. So I have y is equal to negative radical 2 over 2 x minus pi over 4 plus radical 2. This is in point slope form, nothing wrong with that. But since I'm going to show you, I want to check this on my calculator, I need to put it in slope intercept form like that. So let's go to the calculator and check and see if this works. So my function is secant x, but there is no function secant on the calculator. But I know secant is just 1 over cosine. So I'm just going to go 1 divided by cosine x. Close my parentheses, zoom 6. And here's my graph of the secant function. Now, one of the things I want you to think about here is that my x values here are in terms of pi. In fact, they're in terms of pi over 4. So I can go to my window, and I'm going to change my x scale. I don't want it to go by 1s. I want my x scale to go by pi over 4s. So I want every tick mark to be a pi over 4. So I can just go second pi divided by 4. And now I'm going to go graph. And now each of these tick marks is a pi over 4. I don't need to see this many iterations of it. So I'm going to change my x minimum to be negative pi. And my x maximum just to be pi. Now you can see that the calculator automatically puts in a decimal approximation. But what I'm trying to show you here is that you don't have to stick with integers or decimals. You can use values of pi to do this. So I'm going to graph it. That's looking pretty good. So I can see very clearly now that here's my pi over 4 point right there, and I want to find out whether or not the tangent line that I came up with, whether in fact that is the tangent line. So I'm going to go to my next one here, and I'm going to enter in the function for my tangent line. It was radical 2 times x minus pi divided by 4 plus radical 2. And let's go graph, and there, I'd say it's looking pretty good. I'd say that looks like a pretty good tangent line. Now let's check out my normal line. So I enter the equation for the normal line into the y3, and you might want to pause here for a minute. Look at all the parentheses I had to put in, because I had to make sure that everything was being only multiplied by the things that it's supposed to be multiplied by. And now I'm going to graph it, and whoa, it doesn't look at all like it's supposed to, because they're supposed to be perpendicular, aren't they? Well, the problem is that there's a stupid screen on the TI-84. And when you just have it, I don't have it square, I have it longer horizontally than I do vertically. So if I can see that it's hitting at the right point, but if I want to see whether or not it's actually perpendicular, I can go zoom, and zoom 5 is zoom square. So I'm going to press zoom 5. Now it's going to redraw the whole thing. But we'll see if I get a better picture now. Here comes my tangent line. Here comes my normal line. And yes, I do believe now that they look perpendicular. So remember that if it doesn't look perpendicular and you're checking your answers, you might want to go to zoom square. That is what will make it look perpendicular. Just one other thing you can do to check your answer is you can look and see, well, where are these two lines intersecting? Because they should intersect at our point P. So let's go second, calc, and I'm going to go 5 to intersect. Now, the first curve it's giving me is up here in the top left-hand corner here. You see it? It's giving me my secant function. I don't want that one. I want my first curve because I can only pick two curves to intersect. So I want my first one to be my y2. See, now it says y2 up here in the upper left-hand corner. Hope you can see it. I want that to be my first curve. And my second curve I want to be y3. I press enter. I'm not going to make a guess. And I push enter. And it tells me my intersection is at y equals 1.41. Well, I know that 1.41 is pretty close to radical 2. And what is pi over 4 equal to? So it says 0.785. So I can quit. I'm going to go pi divided by 4, 0.785. So they have intersected at the right point. Another way of checking my answer. If I did this graphing on Desmos, it would probably be a little bit easier to read and more properly to scale. You can stop right here. I'm going to actually go ahead and put it on Desmos so you can, just so I can explain a few more features of the Desmos graphing calculator. So I put it into Desmos here, and one thing that you can see is kind of interesting is I can actually enter in the equation in point-slope form. And it showed up my tangent line. And it showed my normal line. You can see more that it looks perpendicular. If you can kind of highlight the points right here, and see it's pi over 4, radical 2 over 2. So, a little bit easier in some respects.